shovel and a pair of dungarees. You will find him in the forest, always sniffing at the breeze. People stop and pay attention when he tells them to beware, 'cause everybody knows that he's the fire-preventing bear. Smokey the bear, growling and a-growling and a-sniffing the air. He can find a fire before it starts to flame. That's why they call him Smokey, 'cause he sure deserves the name.
It's J-Rock and the Geek. We're back for another one. Today's objectives: identify the components that make up an ionic compound, differentiate between a binary and polyatomic ionic compounds, and to identify how to name binary and polyatomic ionic compounds.
So first of all, what is a binary ionic compound? This is any ionic compound that's composed of only two elements. That's why the prefix Bi always means two things. When we say two elements, of course, we mean one metal from the left side of the periodic table and one nonmetal from the right side.
Naming binary ionic compounds is quite easy. The first thing that we want to do is name the metal. Then the second thing we do is we chop off the ending to the nonmetal and add IDE. So here we have sodium chloride. We have a sodium atom, we have a chlorine atom. Sodium for the metal, you name it right outright. Chlorine, chop off the INE ending and you add ide, so it's sodium chloride.
If you're going to do this in the reverse direction and write a formula from a name, we have two different steps. First of all, you got to find the charge of each atom, the metal first, the nonmetal second. Then we're going to do what's called the cross rule. I'll show you how that works. If you're going to write the formula for sodium chloride, obviously you write the symbols first, Na and Cl. Next you look up the charge. Sodium's charge would be a +1. Chlorine's charge would be a -1. The cross rule refers to bringing those charges down. So the -1 for chlorine comes down here to the sodium and tells us to have one sodium. The +1 for the sodium comes down here and tells us to have one Cl. Works every time.
Alright, let's go over another example. We have lithium oxide. Once again, we're going from the words to the molecular formula. First thing we have to do is write the symbols. We have Li and O. We find the charge of the metals and the nonmetals. If you look at the oxygen, that's a 2- charge. So when we do the crisscross rule, we bring just the numerical number, not the charge, down, and we will have to have two Li's. Then we look at lithium. Lithium has a positive charge, so that 1 will crisscross down to the oxygen, so it will be Li2O. We do not need to put the 1 there. By having the oxygen or the O there, that's our placeholder for 1.
So that's all pretty easy. Where this gets harder for some people is when you start to deal with the transition metals. Those are any metals from that middle section of the periodic table. The problem with transition metals is their charges can change. Iron, for example, can be +2, can be +3, so it's different in different compounds. To deal with this, when you write the name of an ionic compound, the name of that compound will tell you what the charge is. Here's how it does it. Instead of just saying iron oxide, because iron is a transition metal, we put a little Roman numeral in parentheses after the metal. That Roman numeral 3 tells you the charge of the iron. So that means iron in this compound is a +3. To write the formula for this, you follow the same rules. Write the symbols, Fe and O. You check the charges of each one. Since oxygen is a -2, you bring the 2 down, and that tells you to have 2 Fe's. Since iron is a +3, remember the Roman numeral tells us that it's a +3. You bring the 3 down, and that tells you that there's 3 oxygens.
Let's do one more example with the transition metals. Everything's the same. We're going to deal with manganese 4 phosphide. That 4 tells us the charge of manganese. Phosphide has a charge of 3-. So when we do the crisscross, after we write our symbols, we get Mn3 for the -3 on phosphide, and P4 for the charge on manganese.
Okay, so finally here we have to deal with what about if we give you the compound and instead of writing the formula, if you have to be the one to write the name. To do this, you kind of have to follow the crisscross rule backwards. Here's why. When you write the name for, or the first piece for the metal, you can't just say cobalt because cobalt is a transition metal. You have to put Roman numerals in to say the charge. Problem is you don't know what the charge is. So when I say do the crisscross rule backwards, what I mean is you take this 3 and you cross it back up to the cobalt, which tells you that cobalt has to be a +3 ion. That's why we put 3 in Roman numerals. The oxygen you don't do anything different with. You just call it oxide like normal.
Alright, our next group are called polyatomic ions. These are different than binary because binary meant 2. Poly is a prefix for many. So we have many ions making up a compound, which is going to make up our ionic compound. We will give you a list of common polyatomic ions. You will not need to memorize these. You will have these for your tests. You will also have these for your final. Just note that this table here is a good piece of information because it tells you all the charges of the ions. So here we have carbonate, which is CO3. Its charge is 2-. So you'll be able to look these up when we ask you to figure out problems dealing with polyatomic ions.
Alright, so now we're going to try and write some formulas that contain these polyatomic ions. It works the same way as before. You just have to remember that that negative ion isn't just one single atom now. It's a whole big cluster of atoms from that list we just showed you. So to do the formula for sodium nitrate, our first example, starts off the same way as always. You just write the two symbols, Na. In nitrate, you just have to remember to go back and look it up in the table. So there it is, nitrate. Its formula is NO3 and its charge is -1. So you write those two symbols. Also, just like last time, you have to check the charges and do the cross rule. Na is a +1, nitrate is a -1. We know that from the table again. If you cross down 1s, remember we typically don't write the 1s, so the formula is good as it is.
Alright, let's do another example of a polyatomic ionic compound. We have sodium sulfate. We know that sodium symbol is Na. We worked with it before. Sodium has a +1 charge. Sulfate we'll have to look up on our table. Sulfate is SO2 with a 2- charge, so this one's a little different. We have a lot going on here. It kind of looks a little disorganized, so I'm going to show you how we can make it more clear to you and anyone else reading your problem. So sodium sulfate, we write down the molecular formula. We have Na2SO4 2-. The reason why we have two sodiums here is because this sulfate has a 2- charge. Alright. A lot of times it's a lot easier so you don't start taking the 4 over to the sodium and things like that by putting parentheses around the compound and then put the charge on the outside. So sodium has a +1, that we don't transfer that over to the sulfate. Sulfate has a 2- charge. We'll crisscross that back to the sodium, so NO2SO4 would be your final answer there. Alright, so we're done with another tutorial here. Today's objectives were to identify the components that make up an ionic compound, to differentiate between a binary, which means 2, polyatomic, which means more than 2 or many ionic compounds, and to identify how to name binary and polyatomic ionic compounds. Remember to use that chart. That will help you out. Binary is pretty easy. Name the metal. The non-metal, take off the ending and add IDE. If you have any questions, bring it to the next class. We'll be happy to help you.